is.
Great, thank you. Let's get started. We are dot on time. We have some people already joined. So I was talking presentation 4, where we were. Anybody remember where we stopped? Virtual machine architecture files. I think we were here. No, I think yes, we were here. So we were okay talking about all virtualization, right? So let's. So before I start, let me tell you what I'm going to do today, right? I will start 4 and start to complete it, and we will start the presentation 5, and 10 minutes we will have again quiz. I hope you are okay, and but this time I hope all of you are able to do it properly. Don't worry about how I will capture the marks, but at least those who tried last time, they have seen that they are able to actually attempt and get the marks also. Is that correct? Maheshwari, you were there last time? Just asking you because since you were talking. Last time you were there? Hello?
Yes, sir. Yes, sir. I was there.
And you were
Yeah,
able
I'm able
to
to do the
complete,
quiz.
and you were able to see the marks also, what you got, right?
Yes, yes, sir. Yes, sir.
Okay, wonderful. So same thing we will do. We will figure it out, that 25 marks I have already mentioned to you. 25
Mm,
marks will be quiz and assignment, or we'll figure it out. I'm
sure, sir.
thinking maybe I will give you guys some case studies, right? I will share some videos for you to look at what is happening latest, right? There are some very nice videos on the data centers, latest things happening. So for example, I'll share one video and I want your feedback. So was it useful? It was best use of time? Was it relevant to your course? And did you learn something? So maybe I will give such opportunities for you to maybe come up with some solution on existing problem. We'll make it little interesting as well as for you to get a practical understanding, because theory, I'm very sure I will be able to complete the course properly, and you will be able to understand concepts, and presentations will be available. I'm trying to upload it on Takshila also. So that will not be a problem, but I'm just trying to figure it out what is the best way to evaluate you on some assignments or some case study or some quizzes, right? But we'll keep doing these kind of quizzes in between so that you can yourself assess and see if you are understanding what I'm teaching, right? At the same time, the concepts need to be very clear on the design side as well as operation side, and overall look at what's happening around us, right, on the data center side. Is that okay? So today's quiz will
Yes,
also
sir.
be just for you to check yourself, right? How do you do it? So don't worry about sending to me or reporting your marks or anything, but that will be based on what we discuss so that you yourself can figure it out. Okay, are you able to get the concepts clear and have the understanding of what we are talking today? Okay, so the video also I will share at the end so that you don't get distracted now. You can look at your leisure. I don't know whether you have time, but you can find some time and look at it, at least scan through it. I like that video, so you can also see and learn something out of it. That's how we'll start. Okay, all okay? Any questions before I start? Anything you want to ask? Okay, great. If you don't have question, then we'll start from where we left last time. I think we were talking about virtual machine architecture and files. Basically, file types are given here. VM user view, VM hypervisor view, configuration file, virtual disk file, support files, file system, right? What it is, and what is the purpose and description. See, this you can read. This material will be handy with you. Unless you have questions, I will not spend a lot of time, but you should know that there is a real hardware at the bottom. Then we talked about, two kind of architecture, right? Bare machine type and then host hardware platform, and these two types. Can anybody tell me what is the difference between this architecture and this architecture, these two architectures? Anybody remember from the previous presentations? See, there is something called bare metal hypervisor, and then there is hosted hypervisor. If you look at this, and this is the our old server system, initial, conventional server system was like this, where there was a hardware, there was operating system, and there was applications, right? This is the old traditional. Then we said hosted hypervisor case, where hardware and this hypervisor, in between there is a OS. And base bare metal one, we have hardware and we have hypervisor, and then each virtual machine will have their some apps and local operating system, right? So this is how bare metal hypervisor is there. So these are the three things, and this same thing is replicated here. Only two traditional one is not given, but these are the two server system, right? So this is, you can say, virtual machine, and this is a part of the hypervisor, how it is architected. Okay, so I will ask few questions. Scan through it. I'll give you a couple of minutes for you to look at it, and I will ask some questions on this. So please look at this carefully and go through it, right? What is VM user view means? So it means, the purpose of this is logical compute system running operating system and applications like physical machine. It is like physical machine, but it is not like physical machine. It is a virtual machine. So virtual machine user view is the first file type. Then VM hypervisor view. This will discrete set of files like configuration, disk BIOS, swap log, etc. And the storage location for this is NAS or SAN. So can anybody tell what is NAS and what is SAN? Anybody can unmute and tell what is NAS means and what is SAN means. We talked about it, by the way, when we were discussing how the memory is connected to the hardware. Anybody can
It is
unmute?
nothing but a storage area network and
Very good. Then what is NAS?
network attached to storage.
Okay, network attached storage, right? So I'll just repeat. Network attached storage is a storage device connected to a normal network like LAN, right? That will store and share the files. And the next one is SAN, that is a storage area network. That means it is a dedicated high-speed network that connects servers directly to the storage. Okay, so it is just is given here, right? So data, where data is stored for this VM hypervisor view, right? So it is basically importance is management, abstraction, transparency to apps. Okay, then configuration file, right? .vmx files. So VM Wave, VMware. Do you know this company, VMware? Do you know about this company? Anybody can tell what is their business?
Yes, VMware, they will be deploy some of the clients to store their data, and like physical plugins and Windows backups, client backups will be stored in that VMware.
Excellent. So VMware is a software company, you can say, and it is known for virtualization and basically cloud infrastructure technologies, right? Whatever is used in the data centers and enterprises, they basically founded in 1998. You should know this was spun up from EMC. Anybody heard about EMC?
Yes, sir.
What is it? What was that company doing?
Um, Actually, it is introduced by Dell Technologies, the DMC production,
Hmm.
and it will be completely for storing
Storage and data
client,
management.
yeah,
Hmm.
storage,
Storage
completely
and data
backup
management.
recording. Yes, sir.
Very good. Excellent. So this was actually basically storage and data management company, right? So they provided the solution for data storage, backup, recovery, right? Data protection, information management, and the large scale data centers were built by the CMC. Okay, good. Very good. So you have the ideas. So please ask any question if you have. I think we are trying to see virtualization happening every level, right? So what is that? We will see. Okay. So VM hardware components, right? Virtual resources. What are those if somebody asks? Like what are the virtual resources? There is a virtual CPU, virtual RAM, virtual disk, huh? Virtual NIC. Anybody knows what is NIC means? NIC? Anybody can tell me what is NIC means?
Oh, I'm not sure on completely, but NIC will be useful for the switches and configurations. There will
Network
be two types.
network
Yeah,
interface card. Okay, generally it's
yes,
called
yes.
network interface card. And if you see the gigabit Ethernet, by the way, I was responsible for integrating first NIC chip, network controller chip with network controller with gigabit Ethernet on the CPU. Okay, so that card is actually separate network interface card. So that we first time on 14 nanometer we integrated into the CPU, because CPU will be separate, server chip will be separate, and the NIC system, whole the network interface card will be separate. Okay, so now we integrated that whole gigabit Ethernet controller, PHY, everything, and the network controller, whole hardware component, right, inside the server. And we said that chip will have both your NIC functionality as well as server functionality. Okay, so there is something called virtual NICs. Did you heard about vNIC? There is a mention there, virtual NIC. What is it? So it is software-based network interface card, and basically it can give a speeds from 10 Mbps, that is the oldest one, to present like 100 gigabits per second speed, right? So for the data centers, right? So you can say there are multiple, servers have multiple NICs, by the way, and those can be for redundancy, for load balancing, okay, and also to manage the SAN or NAS traffic. We just talked about what is NAS and what is SAN. The traffic will be managed by these NIC cards. Okay, so you can say NIC is a network card that connects a computer or a server to the network. Okay. So this is, you can see this virtualization will making sure that all the components, right, that you can see in the hardware. In the traditional data center, this will be like hardware, and then we have operating system, and then you just like a computer, right? But the computer with a large compute capacity, and we have a lot of memory and all that, right? Now, once we do that, we realize, so much data is traffic is going. So virtualization at every level is happening, right? So virtual peripherals, DVD, CD-ROM, floppy drivers, USB controllers, graphic card, IDE controller. Anybody can tell me what is IDE controller? Anybody knows what is IDE controller? What it is? Just if you don't know anything, you can just say whatever you know, or if you don't know, you can say I don't know. Anybody has heard about IDE controller? It's a hardware interface used to connect the storage devices. What are the storage devices? CD, DVD, whatever we are mentioning, to the computer's motherboard. So IDE controller, okay, is a hardware interface used to connect storage devices like hard disk, CD, DVD drives to a computer's motherboard. So this ID controller, okay, is, you can say, built into the drive itself sometimes, right? So that is why it is called integrated drive electronics. Okay, so IDE, integrated drive electronics. Okay, so what devices use IDE? So hard disk drives, CD-ROMs, DVDs, or any older storage devices. Okay, and how it works? Actually, there is something called PATA, SATA. You heard about parallel ATA, serial ATA interface, right? They uses that, and there will be different drives per cable, and they connect it, right? So there is something called master slave mechanism and all this. Basically, they parallel data transfer or lower speed compared to modern interfaces, right? PATA, right? But right now PATA is nobody's using. This is old thing, but you can say this is IDE. Just again repeating, IDE is a controller, is a hardware interface. It is used for connecting the storage devices like hard disk, CD, DVD to the computer's motherboard. Okay, and then there is interface ports like serial, parallel. There are so many ports are there, right? Mouse. These are all has to be connected to the hardware, right? So they for legacy support. You have so many interfaces. Every interface has some purpose to use, right? USB, motherboard has to be connected through USB, right? LVDS interface for display, or now there is IDP. There are many PCI Express graphics cards are there, right? So you will have SATA PATA for memory connections. So all these interfaces are useful. Right now HDMI. Now you see so many things are there, different interfaces, right? So if I ask you a question, what are the different interface ports available on the server system? Can you keep telling me? Interface ports on the server system. If you see any server system, what are those? Anybody can tell?
Oh, I have
Yes,
seen few of the servers like
please go ahead.
regarding Avamar, like there will be a Gen 40 server and Gen 4S servers and virtual machine. These types of the servers I have seen.
Yes, but they will have some interfaces, right? Connecting high-speed fiber connections, right? There is something called SFP. I don't know whether you have heard. Gigabit Ethernet 1G to 10G to 900G also interface, right? There is some
Yes,
LAN card, right?
yes, 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 yes.
Then there is for storage perspective for data connection to the storage SATA, SAS, non-volatile memories like PCI Express can be used. Fiber channel, SAN storage, USB, right? All these are different kind of interfaces used to connect various devices to the server system. Okay. For display, have you heard anything? Can you tell me? Display, input output ports for display. Have you heard VGA, HDMI, display port, right? Yes, you have. Okay. And then there are some expansion interface ports, right? PCI Express slots. There will be for GPU or host bus adapters. There will be PCI slots will be there. And for power interface, do you know what there will be some AC power port will be there. Some redundant power supply inputs will be there. Some DC power like intercom server के लिए they will have some DC power. All these are the different interfaces. So you can say for network there are some, for storage there are some, for display there are some, for expansions like PCI Express and all that, and for power, for AC power, DC power, there will be some interfaces used in the server system. Okay, I hope you are clear. And then in the computing infrastructure, server types and their evolution. What are the different server types? So you can see initially, you can say in the beginning, right? We had a rack mount, they called pizza box or blade servers, if you heard about this, mainframe servers, right? So different form factors are there. Form factor means size, there server types, right? So they have 1U 2U rack servers. So anybody has heard about pizza box? What is pizza box server? Have you heard about this? Anybody knows? Have you heard about it? Yes or no? Pizza box server, basically rack mount. Okay, so pizza box server actually basically is a thin, okay, very thin flat rack mounted server that looks like a pizza box, okay, in shape and size, and that's why the name called pizza. It's a rectangular design, okay. Not for food, but there will be very thin rack servers are there, okay. They fit into the standard 19-inch server racks, okay. they actually basically high density deployment for the optimized data centers, they use that. Okay, and they have sizes like 1.75 inch height and 3.5 inch heights. There are different height boxes are there, that racks are there. Okay, and what is they use for? They use for virtualization, they for use for cloud computing, for web servers, databases, right? Enterprise applications, they use those rack mount servers. Okay. So what are the benefits of having this pizza server, pizza boxes? Because they save a lot of space because they are thin, right? They can easy to scale. You can just keep adding the racks, right? Very nice airflow is possible in that data center, and they are definitely cost effective for large deployments. They are very useful. Okay. And what are the drawbacks of pizza box mount kind of? So they were limited internal expansion, right? Because they internally they're compact, right? They have very less space for disk or GPUs, and sometimes cooling can be challenging when there is a high density inside that rack. Okay, so the examples you can say the pizza box server is a thin rack mounted server, 1U or 2U. Okay, what is 1U, 2U? Have you heard about what is 1U, 2U means? It is mentioned here, it's not that 1U, 2U rack servers is given, right? What is 1U, 2U? Have you heard about this? 1U and 2U. Anybody? Guess? Guess what is it? 1U, 2U rack server. What is it? Just looking at names, you can tell. So basically U means one rack unit. Okay. How many rack unit? Okay. One U means one rack unit. It is a standard measurement of the height. Okay. So one U is nothing but 1.75 inches. That means 44.45 millimeter. That is one U. 2U is 3.5 inches, 88.9 millimeter. So that is the rack height. That's how this one U, 2U rack. Okay. Server systems. Is it clear? Okay. So server functions, you know that it will provide the processing, memory, local storage, and network connectivity for many applications. Okay. And design data center networking, integration of switches, routers, load balancing, analytics for storage and processing, all that, right? So this is all a network infrastructure. Okay. And what is the modern implementation? Software defined networking. So most of the things. And network evolution, what is happening from physical to virtual? Most of the physical machine, physical server to the virtual server, virtual machine, right? So bare metal with centralized management. Okay. So this is a technology shift, and they are nowadays called as microservices architectures, right? And then there is the virtualization impact. What is it? From hardware centric to flexible infrastructure. Okay. So there is a cloud native design is right now doing. And SDDC is software defined data center journey, right? So it is evolution from traditional to virtualized, right? To the finally the most advanced is software defined data center. Okay. So it's a very matured one, and the industry direction right now in 2026 onwards will be all software defined data centers. And you can see the how the whole evolution has started from simple traditional data center server system with only compute resource, memory, and applications to very advanced, very big, huge data centers with lot of advancement. So today's one of the video that I'm going to share with you is a real data center pictures, videos, and somebody is explaining. So you look at it and tell me if you like to see more of that. And there are a lot of, by the way, literature available to understand what is latest and greatest happening on the server systems. Okay. Now in the storage also there is a lot of evolution, right? Initially there is magnetic storage, right? Magnetic storage was the hard disk drives, right? HDD we used to call. in the earlier, right? It's a basically high latency, high capacity, and very low cost, right? But now whatever the next generation, now if you see latest and greatest, right? Next generation is AI ready storage with cloud integration, containers, right? And then consumption based modes means you can add, delete, remove, whatever you know, right? So future direction is all intelligent storage. So can anybody tell me what you understand by intelligent storage means? Whatever you are understanding. So you can read this. This is a very good presentation for you to understand the evolution of data storage that we are doing. Okay. So intelligent storage, if you somebody ask, define or give me overview of what you understand by intelligent storage. Okay, what do you say? So you can say intelligent storage is the modern storage system that can automatically manage, okay, automatically optimize. It can protect and analyze the data using software analytics, and sometimes now they are using AI ML to that one. So you know that in traditional storage you just have a store and retrieve, right? But now in intelligent storage we think and act automatically, right? So what are the capabilities of the intelligent storage? There will be auto tiering will be there. That means moves frequently use data to the fast storage. SSDs are non-volatile memories, right? And it moves the less used data to the hard disk drive, right? Or they called cold storage. And this happens automatically without your knowledge. So that is called auto tiering. So how to move the data, frequently used data on the SSD and non-volatile memories, because you can retrieve faster. And if the data is less used, then you move to the hard disk drive or somewhere, right? Not required. And data duplication and compression is one of the latest intelligence storage system do. That means it will remove the duplicate data. It also compresses the data to save the space. Okay. And somehow overall it will try to reduce the cost of the data storage. Okay. And fault detection, self-healing, these are the features of intelligent data system, right? So they detects disk failures early. They can automatically rebuilds the data and then improves the reliability, right? And also performance optimization. They will have caching, right? Load balancing, or they call QAS. Anybody knows what is QAS? Quality of service, right? So there will be security and data protection. That means there will be encryption, okay, or they can take the snapshots we talked about, replication of the data, okay, and they can have some software which can detect the ransomware detection, right? Modern systems may you will have some way to detect some security problem in your system, right? So when you use so where you use the intelligent data systems, now present data centers we use the intelligent storage systems, right? Cloud storage platforms, right? Virtualized environments like VMware, enterprises where we need a lot of SAN, NAS kind of data, right? And big data workloads, right? AI and big data workloads, you need intelligent storage systems, right? I think you can understand that, in summary, what you should say is intelligent storage is the storage that automatically optimizes the performance, it optimizes the capacity, and also it will help you to store the data with basically security, and you can do the analytics using some software and all that. Okay, so that is the intelligent system. So rest of the things you can write. Each word I will not write, but please go through this presentation and ask for the questions, right? So when somebody says what are the scalability solution available for you, scale out architecture enabling better utilization and flexibility, right? So they called horizontal scaling, right? The hyperscale model. So we have heard about hyperscale model, right? Anybody can tell what is hyperscale model means? Anybody can describe what is hyperscale model means? Have you heard hyperscale model? Okay. So basically, hyperscale model in the data center is, or in any IT architecture is, to basically help you scale extremely fast by adding large number of low cost servers, storage and networking units. Basically, all these are critical components. In the first class we learn, right? What are the critical elements? They are computation servers who serve the data, storage and networking units. But in the hyperscale model, what it will do? It will very fast, it will scale it. Means it can up or down, whatever, right? Scale fast by adding large number of low cost servers, storage and networking units, and you can always scale it and scale down, whatever. So instead of making one system very big, right, that hyperscale will add many systems, right? And that is called scale out. So this word you please remember. Scale up means making one system very big. That is called scale up. And scale out means hyperscale will add many small systems together, right? That is called scale out. So basically, tens of thousands of servers and millions of users will be supported on that server, right? So in the scale out architecture, what happens? You add more servers to increase the capacity. There is no need to replace the existing hardware. You can keep it, you can keep adding or subtracting, whatever way, based on the need, right? So the community hardware is basically standardized, cost optimized servers, right? Often basically custom design. They call it white box. Okay. So if you heard about this word called white box, you can say that is a custom designed server system is called white box. Okay. And right now, trend is everything is software defined, right? That means software defined compute, software defined storage, software defined networking, right? And there is a huge, very heavy use of virtualization and containers, right? So there is a lot of automation happening, right? AI driven monitoring, auto provisioning, self healing systems, all that is the latest trends. Like examples, if somebody asks you who uses hyperscale model, and can you give the companies who do these hyperscalers, like you can say Amazon AWS, Microsoft Azure, right? Google's GCP, Meta's Facebook, Alibaba. These are all using the hyperscale models. Okay. I hope you are getting this. So now storage evaluation, I think we talked. This is, you can read the year wise, what is it? I am not going to spend time. Okay. But let me just explain you the difference, right? So flash. Anybody can tell what is the flash memory, what is volatile and what is non-volatile? That much you understand? Can you give flash memory examples? Anybody? Flash memory. This is one of the storage, right? It's a volatile or non-volatile flash memory? You can.
Volatile.
Non-volatile.
It is non-volatile. Okay. Flash memory is non-volatile, please. Okay. Because it stores the data when there is a power. Non-volatile means it will store the data even when power is off. That is called flash. Okay. Like a RAM is a volatile because when power goes off, data will go off. But non-volatile memories will, even if power is off, the data will be still there. So flash memory is non-volatile memory. So because it is used, it is very fast, very compact, and very durable. And flash memory, there are two types that are very famous. Which are those? NAND flash, NOR flash. Have you heard about it? Types of flash memory. You have heard, right? So NAND flash is like SSDs, pen drives. These are all NAND flash. Okay, and NOR flash are like a BIOS, or embedded systems. They use the NOR flash. Okay, so like a USB drive, SSD, memory cards. They're all examples of flash memories. Okay. Can somebody repeat what I said? What are the examples of flash memory? USB drive, SSD, solid state drive, like you can say semiconductor memory drives, and then memory cards. Okay. These are the common example of flash memories. Okay. Flash memory is a non-volatile. There is no moving parts in that, and it is faster than the hard disk drive. Okay. So you can remember there is NAND flash and NOR flash, and there is other, it is you can say in servers and today's data centers, it is very widely used. Okay, so you can go through this presentation, and if you have questions, please ask me. I will wait here 2 minutes. Let me see if you want to ask any question. Anybody want to ask question on this? Any memory, how the evolution, or what is AI ready? What is happening? What is SCM? Can somebody tell what is SCM? You see, there is SCM, right? AI ready next generation memory. Anybody can tell what is SCM? Anybody has heard about it, SCM? There is a lot of such words will come. At least you can ask, because this is all finally end of the day. Basically, it's a storage class memory. Okay, SCM is storage class memory. SCM. Okay, remember this word. SCM stands for storage class memory. This is very latest. Okay, so what is this? This is used in the IT data centers, right? SCM is a type of the memory that sits between the DRAM and NAND flash. SCM. Okay, so it is definitely faster than SSD and flash, but definitely it will be slower than DRAMs, but it is non-volatile. Okay, so basically you can think hierarchy, right? Memory position. CPU is there, DRAM, SCM and NAND. Okay, so NAND is a flash memory, correct? Non-volatile. SCM is also non-volatile. DRAM is fast but it's volatile, and then CPU. So basically CPU will take the data from each of these memories, DRAM, SCM and NAND. So you can say SCM is sitting between the NAND and DRAM. It is definitely faster than uh, which one? Faster than SCM is faster than what? SSD and flash. Okay, it is faster than SSD and flash, and it is sitting between that. So SCM stands for storage class memory. Okay, so this is basically non-volatile memory. Data is retained after power off. So this SCM memory, it has low latency because much faster than SSD, and it is byte addressable like a RAM memory, and very high endurance. Okay, so example, somebody asked what is the SCM memory examples. So there is Intel Optane is there. Okay, 3D Crosspoint, you have heard about it. Okay, actually they discontinued it, but Micron and Intel had a joint venture. Okay, 3D Crosspoint memory. So this Intel's Optane is an example of SCM. Okay, now there is a PMEM is there, something persistent memory. Okay, and right now presently the SCM examples are MRAM and RRAM. Have you heard about MRAM, RRAM? Anybody? MRAM and RRAM? No? Have you heard at least? Or RERAM? These are very latest. Okay, so big companies, right? Basically MRAM is magneto resistive random access memory. This is again non-volatile memory. Okay, so basically there is something called magnetic tunnel junction. Okay, so this is a magnetic states. Instead of electric charge, they use the magnetic states, and data is stored 0 and 1 based on the magnetic orientation. Okay, so just to, if you want to tell about MRAM, you can say it is a non-volatile memory. It is very fast, exactly like SRAM, like speed, very high endurance, almost unlimited. You can read right nowadays they are claiming, but very few companies had it. Okay, MRAM, and most important benefit is it is a low power. Okay, so there are something called STT MRAM, SOT MRAM, all there are there. Okay, so where they are used right now, they are used in the like embedded memory in the SOCs, cache replacement, automotive electronics they are using a lot, right? IoT and industrial systems, MRAMs are used. And then there is another memory that I told, RRAM, resistive random access memory, right? Basically, that it just use the idea of changing the resistance of the material, right? Actually, they use the metal insulator metal, the MIM structure. They call MIM, metal insulator metal insulator metal structure. And data stored as a high resistance means 0 and low resistance means 1. So they have this mechanism in the RAM. Okay, definitely it is non-volatile, very simple structure, and it is very small size, by the way, and definitely much lower power operation. So RAM right now is used in a neuromorphic computing, storage class memory, right? SCM we talked about, and then in the embedded memories or wherever you need high density storage, right? RAM is being used. It is a non-volatile memory. Okay. Okay, RAM, MRAM. Just I don't know whether it was not there, but SCM is, one of the RAM, MRAM is of the SCM. This is latest right now happening. Okay. There are very few companies who have production worthy such memories available for various applications. Okay, hyperconvergence, SCI, what is it means? Okay, so we have virtualization, right? We have storage, we have networking, servers, and virtualization, and now hyperconvergence. Okay, what is hyperconvergence means? Can you read through this, please? Hyperconvergence, SCI, hyperconvergence. See what is happening. What is the definition of hyperconvergence? Means integrates compute, storage, networking, virtualization into the single software defined platform. That is like a cross 86 platforms that, okay. So example is Nutanix platform, all in one solution, basically, right? So who use it? This is called hyper converged infrastructure, SCI. Hyper converged infrastructure. That means this will have everything: compute, storage, networking, virtualization, everything combined into the one single system, and it is managed by the software. So software defined platform. Okay. So instead of traditional like separate server, SAN storage, network devices, so that everything will run on the same x86 servers, right? So if you asked what is the traditional data center versus HCI, you can say in traditional data centers you will have separate server, but in HCI there will be combined node. Okay, there will be separate SAN in the traditional servers, but in the HCI it is software defined storage. Okay, and it is the setup for traditional is complex, right? Because you have to do manually, humans are involved and all that, but HCI simple deployment is possible. And uh, traditional is a hardware centric, all these components you have to connect it, but HCI is software defined. Okay, so definitely components are same: compute, storage, networking, right? But how HCI work is, each server is like a HCI node they call, then multiple nodes, they form the HCI cluster, and the storage is pulled using the software defined storage, and it is managed from a single console. Okay, so that is the HCI. Okay, so if you are asked to give examples of popular HCI examples, you can say Nutanix. I just give the name. Okay, HPE, SimpliVity, Azure's Stack HCI, and then VMware's vSAN is there. So please remember these names. Maybe I will send you one separate notes on HCI. Okay. So benefits of this is it is easy to scale. You can add node or you can increase the capacity. It is very low cost that in than traditional one, right? And very simplified management, right? High availability, you can say. Okay. So HCI is an architecture that integrates everything. Okay. Cloud type and deployment modes. So there is, we actually in the first class itself I was telling, public cloud, private cloud, hybrid cloud, right? Hybrid examples, right? Okay, cloud servers and benefits, right? Public is like third party data centers, right? AWS, Azure, these are GCP, right? VMware, these are all basically very affordable, less overhead, because you can just go to these guys and say, I need this much compute, this much memory, and I will pay you for 1 month, or 2 month, or 6 month, and once I'm done, you can take your services. Or for somebody who just need to increase the storage or increase the compute resources, they can just ask it. You can rapidly scale it and scale down whenever you need it. And a private cloud is like a corporate data centers, like as a cloud on premises, resource control and compliance and data sovereignty is there, because they do it for themselves. They don't cannot be giving it to others, right? Private one. And hybrid means some on premises and some from the public cloud. That is hybrid. And hybrid examples are like retailer database will be there on the um, on premises, and then website will be on the cloud. So it is like a hybrid example, right? And in the cloud servers, you can see the example, the private cloud, hybrid cloud, and how cloud computing and then public clouds, how it happened. The picture, that big picture can give you the idea of what are the different cloud types and the deployment models, right? So cloud servers like on-demand services like OpenStack, or consumption-based model, right? Flexible scaling. You heard about SaaS, PaaS, and IaaS. Can anybody explain what is SaaS, SaaS, PaaS, and IaaS? Okay. Anybody can give the long form? Software as a service. Then what is PaaS?
Platform as
Platform
a
as a
service.
service.
Excellent. And what is the last IaaS?
Infrastructure as a service.
Infrastructure as a service.
Wonderful. Great. Okay. Excellent. So you have ideas. Key drivers for data center transformation. It is very, very clear. Okay. There is a, um, you know, various, right? You can see the no spin zone. That means move from magnetic hard disk drive storage to the flash, or we talked about MRAM, RAM, and all that, right? Or improved IO performance, latency, density, power, all those improvements are, storage revolution on that. Then monolithic, right? We talked about monolithic memory array versus now software defined, right? All systems are distributed now. Then convergence, and convergence emergence means from traditional silos to the converged, then hyper converged infrastructure models, right? So cloud role, virtualization benefits, extended performance, availability, cost optimization drivers, right? So basically it is helping you to get the market expansion, and people are calling cloud first strategy, right? Anybody can give me some insight into what is cloud first strategy means? Can anybody just describe it, what it means? Cloud first strategy, have you heard about it? So this is the IT or data center server, or any enterprise organization's priorities, that cloud computing over on-premise infrastructure for all the new applications and services. That is called uh, cloud first strategy. So that is a first choice, not a default or last option. This is a first choice. Okay. New applications, new services, you just go for cloud. Okay. And how this cloud first works? When a new project starts, decisions order will be like this. Should I go to public or private cloud? Should I go to hybrid cloud? Should I go on premise? That is last option. Okay. The on premise is the last option. So cloud is default. That is called cloud first strategy. It is by default cloud. Okay. On premises only by exceptions. Okay. They use heavy virtualization, containers, managed cloud services. By the way, anybody can tell what is containers means? Have you heard containers? You heard containers? What is containers means? Containers are the lightweight way to package and run applications, okay, along with everything they need, like code, libraries, dependencies, everything they put it, right? So you can say that on the same operating system kernel, unlike virtual machine, they will put it. That is called container, okay? So container is, you can say, portable, isolated environment that runs an application consistently across different systems. That is called container, okay? That means the app dependencies are all bundled into a single place, right? Containers share the host operating system and kernel, but it will the like everything, you can say, dependencies and all that will be bundled together. So if somebody asks you containers versus virtual machine, what is the difference? Can you give some examples? Which size will be larger, container or virtual machine? Container small, okay, size. Virtual machines large, gigabits range, okay. Operating system, containers will share the host operating system, but in virtual machines, each virtual machine has its own operating system, okay. If you say containers, startup time within milliseconds, right? But virtual machines, it can take minutes. Performance wise, containers like a near native, very fast, right? Virtual will definitely little bit slow, okay, little slight overhead is there. And density, if you see, containers very high density, virtual machine so lower density, okay. So just to give you the idea of what is container means. Okay, real world case studies. Okay, Google data center, AWS, IoT, and S3. We talked about this in detail last time. Microsoft underwater also I talked, right? Cisco HCI strategy, enterprise VDI. What is VDI? Enterprise VDI. Anybody knows? Enterprise VDI. What is VDI stands for? So a lot of words are there, so you should know what is enterprise VDI means. VDI is virtual desktop infrastructure. Okay, what is VDI? Virtual desktop infrastructure. So it is a technology where desktop operating systems run on the centralized server. That is called VDI. Okay, in the data centers or on the clouds also. Okay, so basically instead of running the Windows or Linux on the local PC, the desktop runs as a virtual machine on a server. So that is called VDI. Is it clear? Again, repeat. I will repeat. Okay. What is enterprise VDI? Enterprise VDI is a virtual desktop infrastructure. VDI is virtual desktop infrastructure. This is a technology where desktop operating systems run on centralized servers. Okay. So users will access them remotely. Okay, but it runs on the centralized servers in the data center instead of or it can run on the cloud also, and users access them remotely. So you can say instead of running the Windows and Linux on a local PC, the desktop runs as a virtual machine on a server. So that is VDI. So enterprise VDI delivers the secure and centrally managed virtual desktops to use over the network. Virtual desktop. You can see the name. AI ready data centers, Google, Meta, AWS, basically GPU optimized, all NVIDIA, right? 430 lakh crore today valuation, $5 trillion. Okay, is amazing. GPU optimized, high speed interconnects, next generation computer, all AI ML workloads. This is AI ready data centers. Okay. Okay. The next session, okay, software defined data centers, we will talk about this today. Okay, I will stop here, but I want to see if you have questions. Okay. Questions? No questions? Questions? Okay, let me start with the next presentation, that is 5. Okay, may not be able to finish everything today, but we will go slow. Okay, so what are the topics in this presentation? Okay, this we talked. Okay, this today's this contact session number 5. It will have what is server means, what is the understanding of the role of the servers, server hardening means what, then there is enterprise software defined data center, then uh, how the hardware is commodity now. Okay, and how the shift for software defined compute, software defined storage, software defined network, and software defined security, all this is happening. So we'll talk about that in today's presentation. Okay, so I think you are aware that software defined data center virtualizes and delivers all the infrastructure, everything, compute, storage, networking, security, everything together, right? And the management, provisioning, and policy information are all performed in the software rather than manual hardware configuration. Nobody is doing now manual hardware. Everything is set and somebody will do it through software. So idea is deliver the IT as a service, ITTS, okay, ITTS, IT as a service with policy driven automation and pooled resources. This is all about software defined data center. Okay, so why did we go with this? Because there is a growth of dynamic workloads, cloud styles. By the way, anybody can tell what is workload means? Anybody can explain what is workload means? What is workload means? You heard this word, but what is it? What is workload means in the server system? When you say workload, can you give examples? See, this there are different systems, right? Server, cloud, CPU, storage, applications, all that is, what is a workload is the amount and the type of work that a system, what system is either server, cloud, CPU, all that is handling. So what it handles, what is the amount of data, you can say amount of traffic or type of the work it handles, that is called workload, right? So in the IT it says, it means what is it running, how much resources it requires, how much compute resource, how much memory it needs, how much networking bandwidth it is consuming, all that is called workload. So in a simple word, a workload is any application, any process or task that consumes the compute resources. Compute resources, memory, CPU, GPU bandwidth or networking bandwidth and all. Okay. So it will use all the processing, memory, storage, network bandwidth, and for AI and ML kind of application, GPU, it will use that graphics, how much it is used, right? So that is called workloads. Okay. So dynamic workloads are there, different types, different capacity, different amount of work it is, right? So we need to have this software defined data center. We have varied needs. So hardware heterogeneity and hardware centric silos made manual operations slow and error prone. That is why we go for software defined data centers. Need for consistent operations across on premises, edge or public cloud, everything hybrid or multi cloud. Okay, and rise of the software primitives like SDN, software defined networking, SDS, software defined storage, and the mature hypervisors and um, orchestration tools are available now. So that should be used in SDDC. Okay. So if somebody asks you what are the typical SDDC components in the architecture, so you should say SDS, software defined storage, SDN, software defined networking, SDDC is the software defined data center that will have all the features to manage the whole data center, and orchestration, that means policy engine, anything you want to do with it. By the way, these are the examples. And security and policies, micro segmentation, centralized policy enforcement, all that is done in the software defined data center, and these are the components of SDDC. So how to enable the SDDC? Okay, SDN controller and virtual switches will be there. Okay, virtual switches, vSwitch. We just talked about CPU, VM, right? Virtual machine, everything, virtual networking, so much, right? SDS is SDS. Anybody has heard of SDS? What is SDS means? SDS. In this presentation, you see SDS word is used. SDS, software defined storage. This is related to memory. So basically, you can see SDN in software defined networking, SDS is software defined storage, and then IaaC. IaaC is infrastructure as a code tools. This is different. Can anybody little bit talk about IaaC? Anybody? IaaC, infrastructure as a code tools. IaaC. Anybody? Hello? Whatever you know, at least long form you know, right? Infrastructure as a code. Huh? Infrastructure as a code. So basically, that means a method of managing and provisioning IT infrastructure using the code. Okay, instead of manual setup, you use a code. That means they use this word, like you can say servers, network, storage, and cloud resources are defined in some configuration file. That's why it's called code. Okay, so that is defined in the configuration file. So how it works? So basically, infrastructure is written in that code file or configuration file. That's why it's called code file, you can call. The code is stored in a version control. You know that JIT is a version control, and the tools will automatically create or update the infrastructure. So that is called IaaC. Okay. So if somebody asks you what are the common IaaC tools, can you give example? For from AWS, there is something called cloud formation. Azure will have some BICEP. I don't know whether you heard, or ARM. There is Ansible. There is Pulumi. There are different common IaaC tools. So maybe I will send this also as a note to you. What are the IaaC tools available today in the market? So if you want to just answer the question on, let's say, what are the benefits of IaaC? Basically, automation and speed is the benefit. Consistency and repeatability, another benefit. Version control, you can do easily. And human error can be minimized because this is automatically done. So it can support DevOps and CI/CD. What is DevOps? Do you know? Anybody knows what is DevOps means? Have you heard this word? DevOps. Have you heard DevOps? DevOps is a culture and setup practices that combines the Dev means development and ops means operations to deliver the software faster, more reliable, and continuously. So that is called DevOps, development and operations. So actually it removes the traditional gap between the developers and the IT operations. Both is together now, DevOps. Okay. So in a simple way, you can say DevOps is a way of working that automates and integrates the software development as well as IT operations. Okay. So it will focus on continuous deployment, continuous testing, continuous integration, continuous deployment, and continuous monitoring. These are the focus areas for DevOps. Okay. Okay. Telemetry, observability, software agents, metrics, and logging. What is it? Can enabling technologies for all that. Okay. What is this telemetry? Anybody can tell what is telemetry? You guys are there? Telemetry. What is telemetry means? So this word you see is in this presentation. There is a telemetry observability, right? Software agents, metrics, and logging. What is telemetry? Telemetry is the automatic collection, transmission, and analysis of the data. What is telemetry means? Telemetry means automatic collection, transmission, and analysis of data from the remote systems to monitor their status, performance, behaviors. That is called telemetry. So you need some software for that, right? This is basically without any human intervention, you want to do it. So you can say telemetry is the process of remotely measuring and sending system data for monitoring and analysis perspective. That is called telemetry. So what kind of data they collect remotely? They can you collect the data. CPU uses data, memory uses data, network traffic, storage, IOPS. Anybody heard what is IOPS means? IOPS. Guys, IOPS. Have you heard? Input, output, operations per second. This is how they measure the traffic. Okay, IOPS. So that has to be very fast. Input, output, operations per second. IOPS. Okay. So it is a measure of how many read and write operations a storage system can perform per second. So you have a compute resource, computation servers system, and talking to the memory. So this IOPS is a measure of how many read and write operations you can do it on a storage system in per second. So this is called IOPS. Okay. So that means you have to find out what size of data actually we are talking about, how many read and writes we are talking about, right? And why it is important, because that will tell you how much how much databases need definitely high IOPS. You need to do very high reads and writes, right? Then you need to find out how the cloud and enterprise storage capacity is required. Okay, what is the performance of your overall data center? That will defined by IOPS. Okay, generally IOPS is measured like 75 to 150 for hard disk drive. If you have flash memory, there will be millions of IOPS, right? If you have non-volatile memories, it's like 1 lakh to 10 lakh IOPS. So they generally measures how many input output operations per second are happening. So based on the storage type, IOPS will be different. Okay. So basically they want to see IOPS is just telling you the number of operations that you do. And then there is a word called throughput. Can anybody explain me what is throughput means? Should I ask somebody specifically who can tell? Throughput. Surabhi, you can tell what is throughput means? You understand? IOPS means the number of operations, right? How many read write? Hmm? What is the throughput means? One second. Hello. I hope all of you are there. Anybody? Surabhi, you are there? No? Who can speak? Throughput. Throughput is the amount of data that you can handle. Okay. IOPS is the number of read write operations. And what is latency? Kunal, you can tell what is latency means? These words you use, right, very often. Can you type it if you don't know the answer? Can you please type, Kunal? What is the latency, throughput, and IOPS means? So IOPS means number of operations, throughput means amount of data that you handle, and latency means time per operations. Okay, I think you guys are not speaking, so I'll start the test. Can I give you the test? Let me send you the test and see if you can answer. Okay, let me share it, and like last time, you try to answer these questions. 10 questions, 1 mark each, and whatever we discussed, I think you should be able to answer. Let me see. I will share the questions for you. Okay, guys, somebody should speak. Otherwise, I will not know whether you are there or not. So I'm typing the link here. Like last time, you copy it and do it. Okay. So this is a link. Okay. Duplicate and then answer the questions and just check how much you get marks. You guys are there? Who will speak?
Yes, sir.
Thank you, Maheshwari. Please look at the test. Thank you, Shanmukha. Can you please click the link, this bottom link, and try to see if you can answer the questions. I will give you 10 minutes. 10 questions. You don't need 10 minutes, but you try. And once you are done, you can just send the message here. Done, done, done. Wow, somebody already did Lux. Excellent. Shanmukha, hey, how much you got, Shanmukha? That very nice. Salma Begum also finished. Excellent. Oh, okay, they are just trying to finish it. So, guys, music. You mute. Meg also looks like she got it. I think she's trying.
So again, I have to duplicate and do that.
Yes, exactly same thing that you did last time. Okay.
Okay.
You will get the answers yourself. You can submit it and you can see how much marks you got it. Okay.
Okay, sir.
Thank you. I see Survi also started. Okay. Somebody got 10 out of 10. Please send the message to me. Bhavna. So if you guys done, you can just, okay, Survi is done. Very good. Survi, how much you got? Don't mind if you get no 9, 8, doesn't matter. You can verify questions. How much you got, Survi? You can type 9. Good. Not bad. Very
Sir,
good.
if you don't
No.
mind, can you
Yes,
please once
I will
again
do.
tell how we have to submit it?
Yes, I will
So,
tell. I will tell. I
yeah,
will do it. I will share it, my screen, and I will do it
okay,
myself. Okay, let's do it.
yeah,
Okay,
sure.
together quickly. So I'm sharing my screen, and I will do exactly the way you are doing it, and let's do it together. Okay, you can answer the questions. So I am sharing my screen. You are already seeing my screen, correct? So I go to our chat, right? And exactly the same way you going to click it, I'm going to click it. I clicked it, right? So it is saying duplicate it. I will duplicate it. Okay, so once I duplicate it, I get this. Okay, 10 points, right? 10 points, 10 marks, 1 marks each, right? So I will answer. In virtualization, each virtual machine typically runs what? One operating system, right? Answer is here. By the way, answers are given. You can check your answers. Then sorry, this is the first answer we finished. Okay. What is the hypervisor? Is a software layer that enables multiple virtual machines on a single host. That is first. Second, which of the following is the type 1 hypervisor? I think I have shown you type 1. It was there in one of the presentation file, but Microsoft Hyper-V bare metal is a type 1. Okay. In virtualization, each machine typically runs its own operating system. Which of the following is a key benefit of compute virtualization? Compute virtualization means you actually hardware, right? Improved hardware utilization, right? Then compute virtualization helps primarily in what? Consolidating the multiple servers onto a fewer physical machines. Okay. And which benefit allows workloads to move between physical hosts to the minimal downtime equal live migration? I think might have not discussed this, but it was there. I will again talk about it. But virtualization improves disaster recovery. We didn't go to this part, but since this was for this talk, but virtualization improves the disaster recovery primarily by enabling the virtual machines replication and rapid restoration. We briefly talked, but there is separate presentation for this separate file. One major limitation of monolithic storage, this we discussed very detailed. Limited scalability beyond fixed hardware frame, right? This you can answer very well. Okay, which modern storage approach replaced monolithic arrays in a large scale environment? Software defined storage, right? And the last question is, which issue is related to performance bottlenecks in a monolithic arrays, right? So centralized control path is the issue, okay? Because It is hardware defined. If it is, then you can at the virtual software level you can fix it. Right? Now you can say collect responses, then you will get this. Okay, like what Surbi and others were sending. So you can put your email ID or my email ID and send it. Once you
Sir,
send it, I will get it.
uh,
Yes,
one doubt, like up
yes,
you can
please.
see one forms link, right? There,
Yes,
like you've
yeah. You
written.
can
So can you
copy
just
the
copy?
link. Yeah, copy
No,
the
no.
link. Yes,
Once can you copy that link and paste it, because
I
I
will.
want to
I
check
will.
if
I
we
will.
can
I will.
duplicate it or not.
I will
If
do it. I will do
hmm,
it. Okay. So now I just copied the link, by the way, and then
hmm.
I'm sharing with all of you. Okay. So this is the, you can see that now this is the what you get it. Okay. This is I shared with all of you. So if I open it, this
So
verifying the link.
now the link that you gave, right? So we really
Ha,
can't duplicate it, and
correct.
whatever response we give you,
Yes,
it will get stored in your actually drive.
correct, correct. But I'm just,
So
yeah, you
so we
can,
can fulfill this one right now
yes,
because you will be
yes.
getting response.
Yes, you can actually copy that link, put it, and then you get the response from this because there is no answer. I just show you the answers, but yeah, you can do that.
So now, okay, I will submit my form.
Yeah,
So can you just
yes,
check if you are able to record it?
sure, I will check. But for the time being, I'm not recording for each of your marks. It is for your own benefit. You can yourself see it, how much you got it. If you click on the right question answers, right, you will yourself will understand how much marks you got it. Okay, and I'm not recording and I'm not giving you the marks. Okay, this is just for you to benefit and see that you are able to do this quiz. Okay.
Okay, sir.
Okay. Any questions? Anybody has questions? Anyway, I was thinking I will give you some case study or something to study, some videos. Let me share you one video that I wanted to share with you today. You can tell me, by the way, we should try to see if I can play it while I'm talking to you. I want to see if I can play some videos also because very interesting video and it has a lot of useful information. So you will benefit if you go through that video. You will see what is latest happening on the data centers and you can use that video for your learning perspective. Okay, so let me share that video. Um, I'm just pasting the link and let me see if I play this video, can you see it? Let me share my screen. You can see my screen, right? And generally when you screen, you have to somehow do some option where you can hear also.
While screen sharing, if you click on the share button, so
Yeah,
you can see include sound option. So you have to
yes,
stop your screen sharing. So
okay,
in
stop,
that, if you just click on
share,
the share and click
yeah,
on include sound and then
yes,
start sharing your screen, we can
perfect,
hear what you're sharing and we can even hear your voice if you're on mute.
perfect, thank you. I just did that and I am now sharing with you. Okay, share the
Okay.
content, include the sound, and I just shared it. And let us see if you can, just partly I will run it. Okay, there is something called tar switch. Okay, you can hear, you
Yes,
can tell
sir.
me.
We can hear
Perfect,
you, the video and your
wonderful,
voice also.
wonderful. What is a tar switch? It is
Welcome
a
to Tech
network.
Savvy Productions. We're going to be looking at the subject of a Tor switch. You can't seriously read a lot about data center design, software defined networking, co location units, or even internet exchange facilities without hearing the term Tor switch pop up all the time. Now, there's a very accurate definition of what a Tor switch is, and then there's a whole lot of nuances to that definition. Let's take a look at what a Tor switch and why it plays such an important role in specific types of data centers. All right, remember I said technical definition first. If I say I have TOR switch, that means it's top of rack. If I've got a 19-inch rack, whatever component I put on the very top would be a TOR device, a TOR component. In the case of our discussion, we're going to be talking about TOR switches. So that means we're going to take a switch, put it at the top of the rack. The rest of the rack will be servers, storage devices, and we'll tie all the networking to the switch at the top of the rack. So when we're using the word TOR, we're talking accurately and technically about the physical location. Whenever it's at the top of the rack, it's a TOR device. Now, critical network switches that connect all the servers and storage in a rack, if we place that switch at the top, that's called a TOR switch. Now, some data centers take racks of servers, racks of storage, and then at the end of the row, they will put all the switches at the end of the row. Those are called EOR switches, end of row switches. Cabling has to be longer because you've got to run your cabling down to the end of the row to where all your switches are. And there are advantages to having end of row switches versus TOR switches. Another option is middle of the row, MOR, where instead of putting all the switches at the end of the row of where all the racks of servers and storage devices are racked up, we're going to move those switches to the middle, reducing the distance by half. Servers on this side, servers and storage on this side, and they simply come to the middle of that row and they connect to the switches. That's called MOR switches. So let's go back to my picture of my rack of servers and my switch at the top of the rack switch. But what if that network engineer is racking up his servers, racking up his switches, and he decides, you know, it just makes sense to put that switch in the middle of the rack or maybe even at the bottom of the rack. But I'm connecting all the devices in this rack to that switch, no matter whether it's at the top or the middle, at the bottom. 9 times out of 10, no matter where he puts it in the rack, he's still going to call it a TOR switch. I told you this was tricky. So a TOR switch is more than just its location. Now, when describing network traffic within data centers, there's 2 ways of talking about it. And I'm going to loosely call traffic going from in the data center out to the internet and from the internet into the data center, north-south traffic. For the purposes of this presentation, there may be people who would argue that there are other kinds of traffic that could be classified as north-south. But for the purpose of this presentation, bear with me, internet to data center to internet, north-south. Now, there's another type of traffic in data centers is within the data centers. And that can also be within, let's say, Azure. Microsoft has many Azure data centers. And if the traffic goes from one Azure data center to another, that is called east-west. Any traffic within the data center is called east-west. Now, here's the key takeaway. If the most critical aspect of your data center is north-south traffic, you're going to design your data center very differently. If the most critical aspect of your data center is east-west traffic, you're typically going to use an architecture called spine leaf topology. It's in spine leaf topology, that east-west traffic, that the TOR switch shines. So when our data center is designed with the spine leaf network topology or architecture, we typically see top of the rack switch. Copper can be used because we can use twisted pair. We have short distances to the switch from the server. In the rack, we get the lowest cost per rack. It's easy to upgrade that switch. Pull a low bandwidth switch out, put a higher bandwidth switch in, and voila, we're ready to go. Now, the switch that you're looking at is a TOR switch. This is an amazing beast of a switch. It's designed and manufactured by Apps Network. I want you to look carefully at a TOR switch. It has 48 ports of 25 gigs each, and then it only has 8 ports of 100 gigabit Ethernet out. This runs very easily on software-defined networking. Most of the traffic is going to be east-west, right inside this switch. Now, here's a Dell TOR switch. You can see I've got a lot of ports. That allows me to connect all my servers, storage units up to this single switch. I've got a number of uplink ports. These uplink ports will connect me to my spine switch. My spine switch is just a high capacity switch that will connect all the TOR switches to the data center network. Now, if you're a data center that is strictly fiber optic cable infrastructure, then you can use the EOR switch design where you take all your switches and put them at the end of the row. Fiber optics can go a long way. It's generally not used if twisted pair copper is involved in the data center. It's easy to upgrade the switches like Tor. More expensive cost per rack, though, when you do a end of row. You can also do middle of row. You put all your switches in a rack, put it in the middle of the rows of servers and storage units, and then bring your cabling to the center or the middle of the row where you connect all that to your switches. This is about medium cost per rack. It's easy to upgrade the switches. Now, if you're trying to use copper cabling in your middle of row structure, sometimes there are exceptions when the row is simply too long and you get back to the long distance that the cable has to run. That's where copper cabling begins to have a problem. So what are the benefits of Tor? If you're using copper cabling, all the copper cabling stays within the rack. The reduction of cable cost per rack comes by shorter cable runs. Cat7 can be used because you've got shorter cable runs. Cat8 can be used. Modular and flexible per rack architecture can be done. Future proofing for higher speeds. You can pull out one switch, put in a better switch. So those are some of the benefits of Tor. Because so many data centers do their network architecture based on the spine leaf network topology or design, often when you look at literature, white papers, etc., they will use the word Tor and leaf synonymously. In other words, they mean the same thing. Almost always when we have a spine leaf architecture in the data center, the Tor switch can also be called the leaf switch. Many data center designs use the spine leaf network topology. It gets great results when the data center hosts lots of cloud-based applications, especially containers. Containers can be spread across many servers, and you could have a lot of containers on a single server. Say you have an online website, and the various containers contain microservices that make up card authentication, inventory of the store, website that shows all the contents for that online store. And then you have card processing, you have the cart generation, and all of that is microservices spread across containers on 3 or 4 servers, all plugged into the same switch. That traffic is east-west. So you also get great results with virtualized networking. If you're using Hyper-V, VMware, Linux KVM, and Citrix, they work great with the spine leaf network topology. These type data centers really want lower cost per rack, and a Tor switch placement really provides that lower cost. Here's an example of my leaf switch and my spine switch. Notice my leaf is synonymous with Tor, top of rack. You can use more affordable switches because you're plugging 1 gig, 10 gig, 25 gig ports down to server storage, and then you uplink using 40, 100, maybe as high as 400 gigabits up to a spine switch, which is a more expensive and higher capacity switch, and that's going to connect you across the data network. One of the beauties of spine leaf topology is if you use really massive spine switches, your data center can scale very large. Look at this diagram. Let's start over on the left-hand side. A two-way spline, and we're talking about pretty beefy spine switches with pretty high capacity with top of rack switches can support up to 6 10 gigabit interfaces. Now let's move to the center. We've got a 4-way spine sitting on top or connecting to our top of rack switches. Now it all depends on the bandwidth and capacity of those spine switches. But here a 4-way spine could give you potentially 12,000 10 gig interfaces, and then on the right we see 16-way spine up to 100,000 10 gig interfaces. So you can see the spine leaf topology provides a very scalable pathway. This brings us to another term, hyperscale computing. Companies like Scaleway, Switch, Alibaba, IBM, QTS, Digital Realty Trust, Equinix, Oracle, Facebook, Amazon Web Services, SAP, Microsoft, and Google have this tremendous ability to scale their computing and their network. That's what spine leaf topology is all about. So spine leaf or spine Tor data center architecture design provides lower cost design for the data center, gives incredible incredible east-west traffic, really good for cloud applications, hyper-scaling capability, really desirable for many data center designs. Another important part of this design is latency. Because each Tor switch is only one hop away from another one, that east-west traffic has low latency from one top of the rack switch to another if necessary. Now, a couple interesting facts about spine leaf topology data center design. One, it removes the need for spanning tree protocol. Instead, they use what's called equal cost multipath routing. They also increase use of fixed port switches and the network backbone. More cabling to purchase and manage, giving the higher interconnection count. It's a more scale out versus scale up infrastructure. And it doesn't require re-architecting the network. There's really no downtime to scale out. If you're thinking this architecture is just for cloud application data centers, no. It works great for TV production studios and movie production studios. So the applications for Spine Leaf are both TV production, movie production, cloud-based applications are very popular applications for this design. So I know what you're thinking. What about Netflix? What about Hulu? What about Amazon Prime streaming video services? Well, they don't use Spine Leaf because it's east-west. If you think about streaming services, it's all north-south. So this is a typical Cisco design for a streaming video service data center. Keep in mind, using copper cable or twisted pair in a rack lowers that cost, but still provides that high bandwidth. When you use a Tor or a More designed data center, you still can use Cat 6a, Cat 6, Cat 7, Cat 8. Remember, Cat 8 is growing in its use in a data center. It provides 30 meters at 25 or 40 gig base T networking and allows up to 2 connectors between one end and the other. So here's a couple disadvantages of the Tor design. Remember, the traffic needs to be east-west, and if you get too much north-south traffic, you can saturate those uplink, which means traffic is going to be dumped and dropped, which will require retransmission and recomputation, which adds latency. Another problem is top-of-the-rack switches, especially if you use brands like Cisco, HP, Lenovo, and they're not software-defined networking switches, then it becomes more complex to manage them. Who in the world is designing Tor switches and spine switches? You would be surprised. It's not a lot of the big names you would think of, although they do provide those kinds of switches. The Open Compute project was led by Facebook, who found itself building data centers, and the vendors it were using were not really providing what it needed. So it pushed a lot of people to come together to the Open Compute project. This was designed to provide open source and open collaboration to hardware and try to build the pace of innovation to lower cost, yet provide the kind of hardware, software, all the needs of a data center without the proprietariness. Open Compute project is impacting server design, storage design, optical transceivers, switch, TORs, spine, you name it, rack designs, router designs, and cabling and fiber infrastructure. Open Compute project is impacting just about every data center on the planet. So in summary, technically Tor is simply top of rack. Tor switches are also known as leaf switches. They lower the cost per rack, popular with data centers with a spline leaf topology. Its placement in a rack of servers could be in the middle, the bottom, or the top, but it's still called a Tor switch. It does not use spanning tree protocol. Cloud applications, virtualization, television studios, movie studios tend to use spine leaf for network topology. Free notes and PowerPoints in the video description below.
How was it, guys? Do you like it? You can hear me? Somebody is there? Okay,
Yes,
there are
sir.
some people. Thank you so much for staying back. I will stop the recording, but I will keep sending you. And if you find